So welcome to this latest video on 162 Maths, and in this video we'll be going over some past GCSE exam questions related to the volume of a prism. Now as always, I'll include a copy of the topic test that we go through in this video as a link in the description, so you can have an attempt at before watching through this video so you can test your prior knowledge. And I'll also include some lesson links that go over this particular topic in greater detail. Now before we get started working through some past exam questions relating to volume of prisms, let's just have a quick overview over what it is you need to revise and remember. Now the first thing is you need to know the definition of a prism. Now prism is where you've got one face that is repeated to make the actual 3D shape. So it's where the cross-sectional area is consistent. Now no formulas for the volume and surface area of prisms is going to be given to you. Now you also need to know that what common prisms there are. So you can have either a cube, which I would say is pretty poor diagram, which can also convert into a cuboid. You've got triangular prisms, you've got cylinders, and you can also have trapezoids, which is basically a trapezium prism. Now the cross-sectional area is always the face that is repeated, so whether it be a square, a rectangle, a circle or a trapezium, that there is the cross-sectional area. Now the formula to find the volume of a prism is basically the cross-sectional area multiplied by the length. Now the length is always can be represented by the height if it's the shape standing up, and that's the cross-sectional area. So as long as you remember those and you remember the basic formulas for area of shapes, then you should be absolutely fine. The cross-sectional area is always a face that is repeated. Now on a cube, that's going to be a square. On a cuboid, it can either be one of the faces multiplied by the length. You can choose whichever face you want. Whereas with triangular prisms, it's always the triangle. Cylinders, it's always the circle. Trapezoids, always with the trapezium. Semicircle ones, again, you need to recognize that one as well. Now the surface area of a prism, although it's not going to be tested on this particular topic test, it is heavily connected. So just a little reminder that the surface area of any prism is the sum of all the areas of each of the faces added together. So again, it's important that you're able to work out the individual areas of each of the faces and then just add it together for the surface area. There are certain formulas you can remember for the surface area, but I'll be honest, as long as you know the definition, it should be relatively easy to remember. Now again, a reminder that if you're wanting access to these questions, all you need to do is just simply click on the link in the description and you'll have access to the questions. So now I recommend that either you have an attempt at these questions before watching through this video so you can see what your prior knowledge is, or alternatively what you can do is just simply pause the video, have an attempt at the question, unpause as we go through the answer and then check if you're correct. So looking at question 1, it says here is a triangular prism. It says the volume is 60 centimeter cubed and it says to work out h. Now this is what we call a reverse problem, where you're given the volume and you need to work out what one of the dimensions are going to be. Now for this particular question, it's always good practice for you to write down the formula. So the formula for this triangular prism is the cross-sectional area, which is a triangle, so that's base times height divided by 2, and then multiplying that by the length. Now the information I know in this question, I know that V equals 60, I know B equals 5 and L equals 8. So substituting those numbers into the formula, what I end up with is 5h divided by 2 multiplied by 8 equals 60. So then if I then get rid of the 8 by dividing by 8, I get an answer of 5h divided by 2 equals 7.5. If I then multiply the 7.5 by 2 to get rid of the 2, I get 5h equals 15. And then if I then divide by 5, I get a final answer of h equals 3 centimeters. Then moving on to question 2, it says the diagram shows two cylinders and it says how many times bigger is the volume of the larger cylinder than the smaller cylinder. So what I need to do is I need to work out the volume of both of these. Now, so here the volume of the smaller one, now for this it's going to be the cross-sectional area, which is pi r squared, times the length, which in this case is the height, so I'm multiplying that by h. So this is the formula I'm going to be using to work out the volume of those two shapes. So looking at this one here, I've got V equals, and it's going to be pi times 2 squared multiplied by 10. So that then becomes 4 pi times 10. So V equals 40 pi. Now I'm just going to leave it in terms of pi for now, but if you wanted to, you can write it as a decimal. So then from this one, using the same formula, I've got V equals pi times 8 squared times 20. So that's going to be 64 pi times 20, and 20 times 64 gives you an answer of 1280 pi. So then to work out how many times bigger it's going to be, well, all I need to do there is 1280 pi divided by 40 pi. Well, I don't need the pi's because they cancel out. I don't need the 0 because they've both got it. So it's going to be 128 divided by 4, which gives me an answer of 32. So how many times bigger is the larger cylinder to the smaller cylinder? It's going to be 32 times bigger. Moving on to question 3, it says that a building block is in the shape of a cuboid. The block contains one steel cylindrical rod with a length of 110 centimeters. The radius of the rod is 6 centimeters. The rest of the block is concrete. Work out the volume of the concrete in the block. So the volume of the concrete is going to equal the volume of the cuboid minus the volume of the cylinder. So what I need to do is I need to work out what these two parts here are going to be. So the volume of the cuboid is simply going to multiply all the three lengths together. Now again, just make sure that all the lengths are the same units. So it's going to be 30 times 25 times 110, which if I type into the calculator gives me an answer of 82500. I then need to work out the volume of the cylinder, and that's going to be pi r squared times L. So then that's going to be equal to pi times the radius, which is 6 squared, times the length, which is 110. So then typing that all into my calculator, I get an answer of 3960 pi. Now I'm going to leave the answer in terms of pi just because it's going to be a lot easier for me to type into the calculator. However, if you've got it as a decimal, that's going to be an answer of 12,440. So then working out the volume of the concrete, using this formula here, it's going to be 82500 minus 3960 pi, and typing that all into my calculator, I get an answer of 70059.29, and that's going to be in centimetre cubed, and that's to 2 decimal places. Oh, don't know what I'm writing there. Let me just stick a P there. Then moving on to question 4, it says the diagram shows a prism with a trapezium cross section. Find the volume of the prism. So the first thing I need to do is to first of all work out the area of the cross section. So the area of the trapezium, now if you know the formula, it's equal to A plus B times H divided by 2. So here A equals 8, B equals 24, and H equals 15. So working out the area of the trapezium, it's going to be 8 plus 24 multiplied by 15, all divided by 2. And if I type that into my calculator, I get an answer of 240. Now I then need to multiply that by the length, so times that by 75, and I get an answer of 18,000, and that's going to be in centimetre cubed. Then moving on to question 5, it says Anthony is going to put boxes in a crate. The crate is a cuboid measuring 1.5 by 2 by 2.4. Each box is a cube of length of 40 centimeters. He does these calculations and he claims that he can put 1,112 boxes in the crate. Evaluate Anthony's method and claim. So let's have a look at what he has done. Now, one of the ways to check to see if his calculation is correct is actually by working the question out. Now, in terms of the boxes can't be broken, they can't be melted and squeezed into empty gaps, which, looking at Anthony's working out, I'm going to assume that that's what he's done. Now, looking at each of the boxes, now imagine that we've got a box, and don't worry too much about which side is going to be the orientation of the box. Now we know that one side has got 1.5, so let's just assume that this is going to be here. Now how many 40 centimeters will go into 150? Well, that's going to be 3. So it's going to be 1, 2, and 3, and there's going to be an empty gap there. Now how many 0.4s can fit into 2 meters? Well, that's going to be 5. So if that's 2 meters, then I'm going to be able to fit 5 boxes there. So 2, 3, 4, 5, and that'll fit quite flush, and then we'll be able to fit 6 boxes going across. So if that's 2.4 meters, then I'll be able to fit 6 boxes going there. So that's going to be 6 boxes, this is going to be 5 boxes, and this is going to be 3 boxes. So the number of boxes is going to be 6 times 5 times 3, which basically equals 90 boxes. So is Anthony's method correct and his claim is correct? No. So Anthony, or his claim, is incorrect, as only 3 boxes can fit along the side, which is 1.5 meters. And again, the total number of boxes you can fit in that crate is going to be 90 boxes. Then moving on to question 6, it says that a water tank is a cylinder with a radius of 30 centimeters and a depth of 120. It says it's filled at a rate of 0.1 litres per second. 1 litre is 100 centimetre cubes. And it says, does it take longer than 1 hour to fill the tank? So first things first, what we need to do is work out the volume of the cylinder. Now we do that by using the formula of pi r squared h in this case. So it's going to be equal to pi times 30 squared times 120. Now we're working in centimetre cubes, so if I type that in, so 30 squared times 120 multiplied by pi, and that gives me an answer of 108,000 pi. Now I'll leave it in terms of pi, but that's in centimetre cubed. So now what I want to do is I want to convert that into litres. And how do I do that? Well, I divide by 1,000. So if I divide that number by 1,000, I get an answer of 108 pi litres. So now that I know the litres and the capacity, what I now need to do is work with the rate, which is 0.1 per second. So from this, if I divide by 0.1, so if I do 108 pi divided by 0.1, I get an answer of 1080 pi. Now that's how many seconds it's going to take. So then to convert that into minutes, I need to divide by 60, which gives me 18 pi. And then if I divide that by 60 again to convert it into hours. Now 18 pi is basically 56.6 0.54 minutes. So I know straight away from there, it's then going to give me the hours. So divided by 60 equals 0.942, and that's in hours. So is it going to take longer than 1 hour? No, it's going to take quicker. And you can just say that it will take 56.54 minutes or 0.94 hours. And there we go. Then moving on to question 7, it says the diagram shows a hollow steel girder in the shape of a prism. The diagram shows the dimensions of the cross section. The length of the girder is 15 meters. The density of the steel is 8.5 tons per cubic meter. And the question is asking us to work out the mass of the girder. Now, in terms of density, that's equal to mass over volume. So to work out mass, it's going to be density times the volume. So what I need to do, I know the density, which is 8.5, but I don't know the volume. So I need to work out what the volume of this girder is going to be. Now the volume of the girder, to work that out, is going to be the volume of the big cuboid minus the volume of the small cuboid. So to work out the volume of the large cuboid, well, that's going to be using the big dimensions. So that's going to be 90 times 45 multiplied. Now I need to make sure that I'm working in meters. So let me just go back and change that. So convert all units into meters. So then this is going to become 0.45 meters. This is going to become 0.9 meters. This is going to become 0.55 meters. And this is going to become 0.25 meters. So working out the volume of that large cuboid, it's going to be 0.45 multiplied by 0.9 multiplied by 15. And then working out the small cuboid, so minus, that's going to be 0.25 multiplied by 0.55 multiplied by 15. So then if I then work each of those volumes up, so I get 0.45 times 0.9 times 15, that gives me an answer of 6.075 minus 0.25 times 0.55 times 15 gives me 2.0625. So then the overall volume is going to be 4.0125, and that is the volume of the girder, and that's in meters cubed. So then all that's left for me to then do is then use this formula to work it out. So mass equals density multiplied by volume. So it's going to be 8.5 multiplied by the volume, which is 4.0125. And if I type that into my calculator, I'm going to get a density value of 34.10625, and that's going to be in tons. Now you could round that up to 34.1 tons, and that's to 1 decimal place, but it's entirely up to you what you want to round it up to. Then moving on to question 8, it says in this question all dimensions are in centimeters. A solid has uniform cross section. The cross section is a rectangle and a semicircle joined together. Work out an expression in cubic centimeters for the total volume of the solid. Write your expression in the form of ax cubed plus 1 over b pi over x cubed. So looking at this question, let's first of all work out what the volume of both these two shapes is going to be. So if I call both these two shapes A and B, so the total volume equals the volume of A plus the volume of B. Now working out the volume of B, or volume of A rather, first, the cross-sectional area is a semicircle. So the volume formula is going to be pi r squared, which is a full circle, divided by 2 times the length. Now here I know that the radius is a half x, and I know that the length is x. So substituting those numbers in, I get pi multiplied by half x squared divided by 2 multiplied by x. So then simplifying this out, I get pi times a quarter x squared, all divided by 2, and that's being multiplied by x. So then simplifying this, what I get is I get x cubed pi, all divided by 8. And that's the volume of A. Then, working out the volume of B, which is a cuboid, that's just going to be x times 5x, which is going to give me 5x cubed. So the volume of B is 5x cubed. So all that's left for me to do is just simply add these two boxes together. So here I get that the total volume is going to be 5x cubed plus 1 over 8 pi x cubed. So here my A value is 5 and B is 8. And there we go.